Hi everyone, today we will continue with the next part of chapter 5, that is network in graph theory. So today we will learn how to identify and draw subgraph and trees. So you can refer your textbook at page 139, example 9. Determine whether diagram 1, diagram 2, diagram 3 and diagram 4 are the subgraph of graph G. So this is graph G. You have vertices P, Q, R, S with H, E1, loop, E2, E3, E4 and E5. So we look diagram 1. Diagram 1 given one part of the graph, that is the vertices P, okay, correct, P, and vertices S, okay, also correct. And the line that connects vertices P and S, the name of the line is E5, same as graph G. So diagram 1 is the subgraph of graph G. We can look at the solution, diagram 1. Okay, diagram 1 is the subgraph because the vertex pair for H, E5 is the same. That means this part, the line that connects P and S, okay, same as graph G. Next, we look diagram 2. You have vertices P, Q, S. The position are same as in graph G, P, Q, and S. But here you can see that there is a loop at vertex P. But in graph G, the loop is at vertex Q. So diagram 2 is not the subgraph of G because the position of loop E2 is not on vertex Q. Next, we look diagram 3. Diagram 3, you have vertices P, Q, S, same position as graph G. But okay, the loop also at vertex Q, same as graph G. But the line that connects the edge that connects vertex P and vertex S, it is labeled as E3. But in graph G, the edge is E5. So diagram 3 also not the subgraph of graph G because the edge connecting vertex P and vertex S is not E3, supposed to be E5. Next, we look diagram 4. Okay, vertices still same, P, Q, R, S. So you have E1. Okay, now the loop. The loop is labeled as E3. But in graph G, the loop is labeled as E2. The line that connects the edge that connects Q and R is labeled as E2. But in graph G, it is labeled as E3. So diagram 4 also not the subgraph of graph G because the loop and the edge connecting vertex Q and vertex R are wrong. So subgraph means is the part of the graph. Next, we look what do you understand about a tree? A tree of a graph is a subgraph of the graph with the following properties. The first one, a simple graph without loops and multiple edge. That means when you say the graph is a tree, it doesn't have loops and multiple edge. Second, all the vertices are connected and each pair of vertices is connected by only one edge. And the next one, number of edge is equal to number of vertices minus 1. If the number of vertices is n, then the number of edge will be n minus 1. So the number of edge we minus 1 with the number of vertices. Next, we look diagram 1. You can refer at page 140. Diagram 1 is a tree. Why? Because all the vertices A, B, C, D and E are connected. Okay, all the vertices are connected. Every pair of vertices is connected by an edge only. That means you have only one edge for each vertices. There are no loops or multiple edge, and it follows the property that if there's a 5 vertices, then the number of edge is 5 minus 1, that is 4. So, in other words, what is tree means? For example, from A, you want to go to E, you have only one way to go. That is, you must go to B, then C, then D, then only you can reach E. You don't have other ways to go to E. To get a clear picture, we look diagram 2. Diagram 2 is not a tree because vertex P and vertex E can be connected in two ways. Here, for example, from B, you want to go to E. Okay, from the position of B, you want to go to E. Either you use the straight way from B to E. Okay, you can use from B to E, or you can make a turn. That means from B, you go to C, then you go to D, then you can reach E. So from B to E, you have two ways. Either you straight away from B, you go to E, or you go to C first, then you go to D, then you reach E. So here, in this case, you have two ways. From from B to go to E, you have two ways. And total vertices that you have is 5. So your edge supposed to be 4. But here you have total edge also 5. So this is not a tree. So you must take note that when we say a tree, it must has only one way that connects two vertices. Next, we look example 10 from your textbook, page 140. Determine whether each of the following graph is a tree. Justify your answer. So we look diagram A. Diagram A. Okay, we just take any two vertices. For example, we take P and Q. Do you have more than one way to reach Q from P? Yes, because you can reach straight away from P, you can go to Q, or you can go to U first, then you go to T, then you can reach Q. Or another way, the longest way, you can go to U, then you can go to S, then you can go to R, then you reach Q. So in this case, for diagram A, you have, for example, from P, you want to reach Q, you have more than one way. So diagram A is not a tree. And another way to check is total vertices that you have is 6. So when total vertices is 6, you must have 5 each. But here you have 1, 2, 3, 4, 5, 6, 7. So you have 7 each. Each pair of vertices can be connected in various ways. So you have, so diagram A is not a tree. Next we look diagram B. So you can check the vertices. You have 1, 2, 3, 4, 5, 6 vertices. And the edge, you have 1, 2, 3, 4, 5 edge. So 6 vertices, 5 edge. Follow the condition. And each pair of vertices is connected by only one edge. That means one vertices, you have only one edge. In diagram A, for example, vertex P, you have two edge. So each pair of vertices is connected by one edge. Okay, that means P to U, you have only one edge. U to T, you have only one edge. So diagram B is a tree. Next, for diagram C, okay, still same, you have 6 vertices. Okay, edge 1, 2, 3, 4, 5 edge. And you can see that each pair of vertices is connected by one edge. Okay, there's only one line that connects each vertices. Okay, for diagram D, okay, still you have 6 vertices, but you only have 4 edge. Okay, 1, 2, 3, and 4 edge. And you can see that vertex T and vertex R is not connected with this P, Q, U, or S. Okay, these R and T are not connected with other vertices. So diagram D is not a tree because it has 6 vertices and 4 edge. The condition doesn't follow, and vertex R and vertex T are not connected to the other vertices. Next, we look example 11. Draw a tree for the following information given. So part A, they asked to draw a tree for when have 6 vertices. So when 6 vertices, you must know that the edge supposed to be 5 edge. Okay, you must calculate that when you have 6 vertices, okay, you have 5 edge. So the condition must follow. So this is example of 6 vertices and 5 edge for diagram A. You can draw up to you. It doesn't matter you didn't follow this diagram. Okay, for example, okay, you draw first vertices. Okay, always remember you want to draw a graph for network, okay, you draw the vertices first. Okay, you put first 6 vertices. Okay, you can any shape, okay, any shape, but please use a ruler lah to draw the edge. Okay, this is example. This is another example you can draw. Okay, you put first the 6 vertices, then you draw the edge. You have 5 edge also. Then the second one, 8 vertices, means you have 7 edge. Okay, like this, 7 edge. So this is one example when you have 8 vertices and 7 edge. Or you can draw in any shape, no? Okay, maybe you want to draw like this. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So you can draw, up to you. You want to draw like this. Okay, this is also a graph, but it's not nice lah, but anything. Okay, each pair of vertices are only connected by only one edge. Okay, for example, this vertex and this vertex are connected by one edge. Okay, this vertex and this vertex are connected by one edge. Okay, so you must follow lah. Then for part C, given 4 edge, so vertices you have to plus 1. Don't forget, vertices must plus 1. So you have 5 vertices, then you have 4 edge. Okay, just draw any diagram. And for part D, 9 edge. So 9 edge, you must plus 1, 10 vertices. So you draw first the vertices. You draw first the vertices. Then only you draw the line. Okay. Then we go to example 12. Draw 2 trees based on the graph given below. So here diagram A is not a tree, but from this graph you have to find the tree. So please remember that first you count how many vertices you have. Okay, how many vertices you have. So what you can do, okay, you have 1 vertices. The position of vertices, make sure it's same, no? Okay, same vertices. Okay, the position are still same. You are just going to take out lines, take out the edge only. Okay, eliminate the edge. So what you can do for example, for these vertices, okay, you have 2 lines. Or this you have 2 lines, and these vertices also, okay, for these 3 vertices, okay, you have a form of triangle here. So what you must do, maybe you can take out this triangle. You can eliminate, you take out this line, take out this line. Okay, then another thing you can see, these 3 pairs also you have this pair. Okay, maybe okay, this pair and this one. Also you have triangle. So when you have a triangle, you can take out any of the line. Maybe you take out this line. Okay, the diagram, they take out this line. And for this 3 triangle, you can take out this line. Okay, so another 3, they draw like this. Okay, you can draw any way. Okay, first what you do, you mark the vertices first. Okay, first you mark the vertices first. Then only you draw the line. Okay, you can draw like this also. You can draw this line. You can go like this. You can come down, and you can go like this. Okay, up to you. Okay, so make sure that the line are connected. Each vertices are connected with one line only lah. Okay, going by one line by one line. Okay, so same here. Okay, you have to draw the tree. So here is the example given, 6 vertices. So total edge you have is 8. So that means you have to eliminate 3 edge. Okay, just now you have 5 vertices. So you eliminate 3 edge. Okay, so now you have 6 vertices. So you suppose you must only have 5 edge. So you have to exit by 3. So you can think how you want to draw. Okay, so first step, always remember you mark the vertices. That will be easy. If you didn't mark the vertices, it will be difficult for you to draw. So you mark the vertices, then you try. Okay, maybe you can try other method also. You want to try like this, to go like this. Maybe you go like this and like this. This one. Okay, that means you eliminate this line. Okay, I eliminate this line. I eliminate this line, this edge, okay, this edge, and this edge. So I get this type of graph. Or you can follow like the answer given. Okay, so they ask for 2 trees. You have to draw 2 trees from the diagram. So make sure there's only one line connects, and it must follow the condition when 6 vertices must have 5 edge only. Okay, next we go to example 13. Okay, at page 141. The following diagram shows an undirected weighted graph. Draw a tree with a minimum total weight. So here you have to highlight the word that is minimum total weight. Okay, so for minimum total weight, that means you have to remove. Okay, you have to remove. First we identify got how many vertices. You have 1, 2, 3, 4, 5 vertices. Okay, when you have 5 vertices, you only can have, okay, follow the condition, that is you must only have 4 edge. But here you have how many edge? 1, 2, 3, 4, 5, 6, 7. So you have to remove how many edge? You have to remove 3 edge. Okay, how we want to remove 3 edge? That means which edge you want to remove? That is the question. So we want to remove 3 edge. Okay, 3E means 3 edge. So we look the edge with the greatest weight. That is 25. So we can remove this line, the line that connects PQ. Okay, we can remove this line. Next, the most greatest weightage is 20. So we can remove the line that connects Q and R. Next is 19. But when you remove 19, what happens? Vertex P, this vertex P, there's no line, there's no edge that will connect vertex P. That means you already removed edge PQ and you remove edge PT. That means there's no edge that's going to connect P. So in this case, you cannot remove 19. So we go to the next that next weighted line, that is 17. 17 you can remove because R, S you can remove here. Okay, so you will have this is the graph given. Okay, so you will have PQ is already removed. Okay, the line that we remove is PQ. Okay, then we also remove QR. Okay, you follow. Okay, why we remove PQ first? Because that is the edge that have the greatest weight. Because the question they ask for minimum total weight. Okay, next we remove QR. Okay, so that is the second greatest. So 19 we cannot remove now, because when we remove 19 means there's no edge that will connect vertex P. So in this case, we have to remove the next weight, next edge that have the greatest weight, that is RS. So remove 17. So you can calculate the total weight 10 plus weight 12 plus weight 14 plus weight 19. So you will get the answer 55. So I hope that every one of you understand the explanation given for subgraph and tree. So thank you for watching.